Hello, let's solve a differential equation given that dy by dx plus y cot x equal to y power 4 cosecant x. Fine. So let's start. Now, as you can see, this is in the form of dy by dx plus p of x into y equal to q of x, but there is y power 4 factorial, right? So let's try to divide the equation, this differential equation with y power 4. Then this becomes y power minus 4 dy by dx plus y power minus 3 cot x equal to cosecant x. So now let's make a substitution here. As you can see, there is y power minus 4 here. So when you take, let's consider z equal to y power minus 3, then dz by dx becomes minus 3 into y power minus 4 dy by dx. Fine. That is minus 1 by 3 dz by dx equal to y power minus 4 dy by dx. Fine. Now this, let's substitute this y power minus 4 dy by dx in the differential equation, which is minus 1 by 3 dz by dx plus y power minus 3 is z into cot x equal to cosecant x. Fine. Now let's multiply it with minus 3 on both sides, then this becomes dz by dx minus 3 z cot x equal to minus 3 cosecant x. Right. Now as you can see, this is in the form of dy by dx plus p of x into y equal to q of x form, right? So let's figure out the integrating factor here. The integrating factor is e power integral of p of x into dx, right? Here the p of x is minus 3 into cot x dx, which is e power minus 3 of this is ln of sin x. Fine. You can see that if you differentiate ln of sin x, which will be 1 by sin x into cos x, which is cot x. Fine. This is e power ln of, this becomes cosecant cube x, right? Finally this becomes cosecant cube x. So integrator factor is cosecant cube x. So let's multiply this integrating factor to the differential equation, which is this. Now this becomes cosecant cube x dz by dx minus 3z cot x into cosecant cube x equal to minus 3 cosecant cube x into cosecant x, which is cosecant power 4x. Right? Now you can write it in the form of a differential, which is d by dx of, right? This is cosecant cube x into z. All right, this becomes minus 3 cosecant power 4 x. Now let's try to integrate. Then this becomes, left hand side becomes z into cosecant cube x equal to minus 3 into cosecant power 4 x dx. Fine. Let's solve this integral. Z cosecant cube x equal to minus 3 into, let's try to write it in the form of cosecant square x into cosecant square x, which is 1 plus cot square x into dx. Fine. Now let's expand this minus 3 into cosecant square x minus 3 into cot square x into cosecant square x dx. Right? Then this becomes integral of cosecant square x is minus cot x, right? As differentiation of cot x is minus cosecant square x. Then this becomes 3 cot x, right? Now here, as you can see here, in this case, let's write it like this. This is cot square x into minus cosecant square x dx. Fine. Then this becomes 3 cot square x plus 3 cot square. This is 3 cot x plus 3 into, and now you can see this is cot x, this is cosecant square x. Differentiation of cot x is minus cosecant square x. Then this is in the form of integral f of x into f of dash of x, f dash of x, which is ln of f of x. Fine. Now here this can be written as, here this is in the form of integral f of x into f of x whole power n dx, which can be written as f of x whole power n plus 1 by n plus 1, right? Here f of x is cot x, which differentiation is minus cosecant square x, right? Then this becomes cot cube x by 3, fine, plus some integration constant. These 3 will get cancelled and we are left with z cosecant cube x equal to 3 cot x plus cot cube x plus a. Fine. Now let's bring this cosecant cube x to the right hand side, that is multiplying with sine cube x. Then this becomes 3 cot x into sine cube x plus cot cube x into sine cube x plus a sine cube x. Fine. Then this becomes cot x is cos x by sin x. One of the sin x will get cancelled. Then this becomes 3 cos x sine square x. Here sin cube x will get cancelled and you are left with cos cube x. And this is the final term, a sine cube x. Right? In the beginning, we have considered this z as y power minus 3. Fine. This can be written as 1 by y cube is equal to a sine cube x plus cos cube x plus 3 cos x sine square x. Now this y cube becomes 1 by a sine cube x plus cos cube x plus 3 cos x sine square x. Right? This can be, if you want, you can simplify it further as a sine cube x plus, now if you take cos x as common, then you are left with cos square x plus 3 sine square x. Right? That is 1 by a sine cube x plus cos x into cos square x plus sine square x plus 2 sine square x, right? Then one of the sin square x will combine with cos square x to give a 1, plus you are left with 2 sin square x, right? Then 2 sin square x can be written as 1 minus cos 2x, right? Then 1 plus 1 minus cos 2x, which becomes 2 minus cos 2x. Fine. Then this becomes 1 by a sin cube x plus cos x into 2 minus cos 2x. This is y cube. This is the general solution for the given differential equation.